Good morning everyone. We are discussing about nomenclature of open chain compounds. Nomenclature of open chain compounds. In the last video, we have discussed the nomenclature of straight chain hydrocarbons. Here, in this video, we will be discussing about nomenclature of branched chain hydrocarbons. In the last video itself, we have discussed that these open chain hydrocarbons are classified into straight chain and branched chain. So initially these open chain hydrocarbons, based upon their saturation, they are classified into saturated compounds and unsaturated compounds, and each compound, saturated compounds and unsaturated compounds, each class they have been further classified into two categories: straight chain compounds and branched chain compounds. So among these, we already discussed in the last class about the nomenclature of straight chain compounds, both saturated and unsaturated. So in this video, we will be discussing about the nomenclature of branched chain compounds, both saturated and unsaturated. So before starting our today's topic, I would like to apologize that in the last video, while discussing about the nomenclature of straight chain compounds that are unsaturated straight chain compounds, I told that while presenting the compound, I have presented like this. That means while explaining the nomenclature of combined unsaturations, I have represented the compound like this. See, this I wrote just to explain how to give the naming when multiple unsaturations are present. Okay, actually the valency of carbon atom will be 4. That means carbon atom will form 4 bonds only. See, in this case, this carbon atom, it is forming 5 bonds, this carbon atom also 5 bonds, this carbon atom also 5 bonds. So we should remember that the carbon atom will form only 4 bonds. Its valency is 4 only. So here I took like this just to explain how we will be naming the compound if it is having multiple unsaturations and combined unsaturations. Okay, so we can write this compound like this. Like this. So this can be considered as an example for combined multiple unsaturations. Okay, so please correct this and please excuse me for the mistake I have made in the last video. Now coming to our today's topic, nomenclature of branched chain hydrocarbons. See, in the last video we have discussed that based upon the number of carbon atoms present in the compound, we are using the Greek prefixes, Greek numericals as the prefixes. So these are the prefixes which we will use when the compound contains respective number of carbon atoms. Okay. Now coming to the branched chain hydrocarbons, let us consider one example. So this is a straight chain compound. That means it do not have any substituents on this compound. So any of these carbons of this compound contains no substituent. So let us say, for example, if this carbon atom is having a substituent. Okay, in this condition, we will call this compound as a branched chain compound. So we can define a branched chain hydrocarbon as the compound or the hydrocarbon that contains a substituent containing less number of carbon atoms that are present in the longest possible straight chain, or we can say that are less carbon atoms that are present in the parent chain. So here, while naming this type of compounds, what we have to do, the first rule we have to follow is we have to select the parent chain. So here in this type of compounds, while selecting the parent chain, we are having two possibilities. The first possibility is like this, then the another possibility like this. So first we have to select a parent chain, then the remaining substituent can be called as side chain. So here in this case we are having two possibilities, and among these two possibilities, to select the parent chain, we have to keep in mind that we have to select the longest possible straight chain or continuous chain, the longest possible continuous chain. So here we are having two continuous chains. So in one continuous chain we have 6 carbon atoms, and in another continuous chain we are having 7 carbon atoms. So here the rule is we have to select the longest possible continuous chain. Okay. So in this compound, the chain that contains 7 carbon atoms will be the longest possible continuous chain, and this chain will become the parent chain. So the name of the parent chain will be, as it is containing 7 carbon atoms, here the name will be heptane, and we have to identify the substituent that is present on this parent chain. So this will be the parent chain, and this will be considered as the substituent, or we can say side chain, or we can say a branch. Okay, so this substituent or side chain or branch has to be named. So we know very well that if one carbon atom is present, that will be considered as methane, and here in the last video itself we have discussed that from alkane, if one hydrogen atom has been removed, then such group can be called as alkyl group. So here from this methane, one hydrogen has been removed and it has been attached to this parent chain. So this can be considered as methyl substituent. So this methyl substituent, or we can say the name of the side chain will be the prefix, and the name of the parent chain will be the suffix. So the name of the compound will be methyl heptane. So here we have to observe one thing, we have to remember one thing. In this case, the carbon atom is present on this carbon atom. So let us say, for example, this carbon substituent is present here or here or here somewhere. In that condition also, this compound will be called as methyl heptane only. Why? Because the longest continuous chain is heptane and the substituent is methyl. So no matter on which carbon atom this methyl substituent is present, we will be calling it as methyl heptane only. So we will be getting confused on which carbon atom this methyl substituent is present. To remove such kind of confusions, what we have to do, we have to indicate or designate the position of this methyl substituent with a numerical. While giving numbering also, we have to keep in mind that the substituted carbon atom should get the least possible number. So here, if we consider the methyl substituent is present on this carbon atom, then this carbon atom should get the least possible number. So from this direction, if we start numbering, the number of this carbon atom, the position of this carbon atom will become 3. If we start numbering from this corner, then the number of this carbon atom will become 1, 2, 3, 4, 5. So number 3 is less than number 5. So we have to start numbering from this direction only. So the name of the this compound will be 3-methyl heptane. So in heptane, third carbon atom is having methyl substituent. So like this, we will be giving name for this kind of molecules. We will consider one more molecule. So let us consider this molecule. Okay, so this is also a branched chain hydrocarbon only. According to the first rule, we have to select a parent chain. How we have to select the parent chain? We have to select the longest possible continuous chain, and that longest possible continuous chain will become the parent chain. So let us see the possibilities here. One possibility will be this, another possibility will be this, and we have one more possibility, this one. So total 3 possibilities are there. So 3 continuous chains we can make. Let us count the number of carbon atoms. 1, okay, I will write with the ink only. 1, 2, 3, 4, 5, 6, 7, 8. So the green chain, the chain represented with green ink contains 8 carbon atoms. The chain presented with red ink, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 carbon atoms then the chain marked with black ink, 1 2 3 4 5 6 7 8 9 10. So 10 carbon atoms. So here we have 3 possible continuous chains. One chain contains 8 carbon atoms, another chain contains 11 carbon atoms, and the third chain contains 10 carbon atoms. So among these 3 chains, this chain that contains 11 carbon atoms will be the longest continuous chain. So this chain will be considered as the parent chain. So the name of the parent chain will be undecane. As it is having 11 carbon atoms, the name will be undecane. Now we have to identify the substituents. So here this will be considered as the substituent because this will be the longest chain. Let me erase these so that we won't be having any confusions. Okay. Okay, fine. So we are considering this as the longest continuous chain. So this will be the substituent molecule here. So this substituent, as it is having 3 carbon atoms, this substituent can be named as propyl group. So here the side chain will be the propyl group. So this has to be the suffix for this compound. So the name of the compound will be propyl undecane. Now we have to designate the position of this propyl substituent. So if we start numbering from this direction, 1 2 3 4 5, so 5th carbon atom will be having the propyl group. If we start numbering from this direction, 1 2 3 4 5 6 7, 7th carbon atom will be having the propyl substituent. So here number 5 is less than number 7, so we have to start numbering from this direction only. So the name of the compound will be 5-propyl undecane. So like this we will be giving naming for the branched chain hydrocarbons. So we will consider, we will see another example. So let us consider this compound. So in this compound, according to the first rule, we have to select the longest possible continuous chain. 1 2 3 4 5 6 7 8. So one chain contains 8 carbon atoms. 1 2 3 4 5 6 7 8 9. Another chain contains 9 carbon atoms. One, two, three, 4 5 6 7 8 9 10 11 12. One more chain contains 12 carbon atoms. One, two, three, 4 5 6 7 8 9 10 11. Another chain contains 11 carbon atoms. Then we have two more possibilities. Yeah, like this: 1 2 3 4 5 6 7 8. Here also 8 carbon atoms, and finally 1 2 3 4 5 6 7 8, again 8 carbon atoms. So totally we have 6 continuous chains, 6 possibilities for the continuous chains in this compound. So in these all possibilities, if we observe, the chain that contains 12 carbon atoms will be the longest chain. So this will be the parent chain, and the name of the this parent chain will be, as it contains 12 carbon atoms, dodecane. So the name of the parent compound will be dodecane. See here, in this condition, yeah. So now our next step is to identify the side chains, or we can say substituents. See, we are considering this as the longest possible continuous chain. On this chain we have two substituents. Let us start numbering. If we start numbering from this direction, 1 2 3 4 5, fifth carbon atom will be having the substituent. If we start numbering from this direction, 1 2 3 4 5 6, sixth carbon atom will be having the substituents or side chain. So according to the rules, the substituted carbon atom should get the least possible number. So here number 5 is less than number 6, so we have to start numbering from this direction only. Yeah. Now, what are the substituents or side chains that are present here? So here one ethyl substituent is present and one propyl substituent is present. So here in this compound we have two side chains. One is ethyl group, another one is propyl group. In this condition, in such type of conditions, what we have to do, we have to arrange the names of these substituents in alphabetical order. So E will come first in alphabetical order. So the names will be arranged as ethyl propyl. Okay, so the name of the compound will be ethyl propyl dodecane. But here we should remember that we have to designate the positions of these substituents, or we can say the side chains or branches. On the fifth carbon atom, propyl branch is there, and on the seventh carbon atom, ethyl branch is there. So the name of the compound will be 7-ethyl 5-propyl dodecane. So this will be the name of the compound, 7-ethyl 5-propyl dodecane. This will be the name of the compound. So what if two same type of side chains are present or branches are present? So in this condition, what we will do, the same thing what we have done in previous condition, the same thing will be done here. First we have to select the longest possible continuous chain, then we have to identify the side chains or branches, then we have to designate the positions of these branches, okay, and we have to indicate with the numericals. So here 5-ethyl 7-ethyl dodecane. Okay, but we won't name the compounds, this kind of compounds like this, because here the two side chains that are present, they are of same kind. So to indicate this, we will be using prefixes like di, tri, tetra, etc. to indicate the number of the same type of side chains present in the given compound. So in this compound, two same types of side chains are present. So we will be naming it as 5,7 diethyl dodecane. The name of this compound will be 5,7 diethyl. That means this indicates on the 5th position and 7th position ethyl substituents are present. Two ethyl substituents are present, that's why we are calling it as diethyl. So the name diethyl indicates the presence of two ethyl substituents, and this two ethyl substituents or branches, the position of these branches or side chains will be designated by the numericals. One branch is on 5th carbon atom, another branch is on 7th carbon atom. So the name of the compound will be 5,7 diethyl dodecane. Let us consider one more example. Yeah, if we see this example, here also this will be the longest possible continuous chain, because 5, 6, 7, 8, 9, 10, 11, 12 carbon atoms. Then if we go like this, 6, 7, 8, 9, only 10 carbon atoms. If we continue like this also, only 9 carbon atoms will come. So the longest possible continuous chain will be the chain that contains 12 carbon atoms, and the side chains or the branches on 5th carbon atom, 1, 2, 3, 4 butyl branch is present, and on the 7th carbon atom ethyl branch is present. So now on butyl side chain or butyl branch, again we have, here in these conditions we have to see the longest possible continuous chain in this side chain also. So here 4 and 5, so 1, 2, 3, 4, or 1, 2, 3, 4, 5. So we will select the longest possible continuous chain. So here the substituent is pentyl substituent. Okay, one is pentyl substituent, another one is ethyl substituent. Now on this pentyl substituent also one methyl substituent is present. So here in this condition, what we have to do, we have to select this as the parent chain, and this substituent, as we do in case of as we did in case of previous conditions, we have to apply the same thing here also. So what will be the case here? This is the pentyl substituent. On this pentyl substituent, one methyl substituent is present. So this will be the parent name pentyl, and this is methyl, and we have to designate the position of this methyl group. So if we start numbering from here 1, 2, 3, if we start numbering from here also 1, 2, 3, so no problem. So this will become 3-methyl pentyl. So this will be the main parent chain. So the name of the parent chain, main parent chain is dodecane, and the main side chain or the main branch on this parent chain will be the pentyl and ethyl. So ethyl and pentyl. So E will come first. That's why we will be writing as ethyl then pentyl. Now what we will do, we have to designate the positions. So on 7th carbon atom ethyl group is present, and on 5th carbon atom pentyl group is present. But on this pentyl group also the 3rd carbon atom is having methyl substituent. So to indicate the presence of a methyl substituent on this branch, we will be designating that within the brackets. So this will be the name of the compound. This will be the name of this compound. So here 7 ethyl, presence of ethyl substituent or ethyl branch on the 7th carbon atom, and 5 3-methyl pentyl, that means 5 pentyl side chain on the 5th carbon atom, pentyl side chain on the 5th carbon atom, and in this pentyl substituent or pentyl branch, the 3rd carbon atom contains methyl substituent. That's why we are indicating this presence of the sub chain, we can say presence of sub chain on the sub chain or side chain. Okay, that will be indicated or represented within the parenthesis or brackets. So these brackets indicates in this on this side chain, on this position, this substituent is present. So here 7 ethyl 5 3-methyl pentyl dodecane. So like this we will be naming the compounds. We will see one more last case. So the compounds like this. Actually, according to IUPAC names, so 1 2 3 4 5 6 7 1 2 3 4 5 6 7. So no problem, we can select either this as the parent chain or this as the parent chain. So here the parent chain contains 1 2 3 4 5 6 7 carbon atoms. So this will be the heptane chain, and as the 2nd carbon atom contains methyl substituent, we will be naming this as 2-methyl heptane. But here the compounds like this, they are having a special nomenclature. So if the 2nd carbon atom is containing one carbon substituent, the 2nd carbon atom is containing the carbon substituent or methyl substituent. So this kind of molecules can also be named as iso molecules, or we can say iso compounds. So while naming like this in systemic nomenclature, while giving the systemic name to this compound, what we are doing, we are considering this as the side chain, and we are not including the number of carbon atoms that are present on this side chain with the parent chain. But while naming like this, what we will do, we have to count the total number of carbon atoms that are present in the compound. So here 1 2 3 4 5 6 7 and 8. So total 8 carbon atoms are present, including with the carbon atoms that are present in the side chain. So 8 carbon atoms means that will become octane. As this carbon atom is present or methyl substituent is present on 2nd carbon atom, we will name it as isooctane. So here the name isooctane indicates the compound contains 8 carbon atoms and one methyl substituent is present on the 2nd carbon atom of the parent chain. Okay, let us consider the presence of two methyl substituents on the second carbon atom. In this condition, we will be naming the compound as neo compounds. So the name of the compound will be neo. As usual, we have to count all the carbon atoms: 1, 2, 3, 4, 5, 6, 7, 8, 9. Nonane. The name of the compound will be neo-nonane. Or if we give systemic name to this compound, 1, 2, 3, 4, 5, 6, 7. So 7 carbon atom chain will be the longest possible continuous chain, that is heptane, and on the second carbon atom we have 2 methyl substituents. So 2, 2 dimethyl heptane. The systemic name for this compound will be 2, 2 dimethyl heptane, because the second carbon atom is having 2 methyl substituents. So we will be naming this compound as 2, 2 dimethyl heptane. So here, with this, we have completed the nomenclature of open chain compounds. If we summarize the points what we have discussed in this open chain compounds, nomenclature of open chain compounds is, so we have to select parent chain. This will be the this is the first point what we have discussed. We have to select the parent chain. Which will be the parent chain? So this is the longest possible continuous chain. So the longest possible continuous chain will be considered as the parent chain. If the compound is unbranched, then no problem. So the compound itself will be considered as the parent chain, and while naming the compound, we will be having prefixes and suffixes. Prefixes and suffixes. So by adding these prefixes and suffixes, we will be getting the names to the respective compounds. So what is prefix and what is suffix, we discussed in detail. So here this prefix indicates the size of the compound, whereas suffix indicates the nature of the compound. That means here the prefix size of the compound means number of carbon atoms present in the compound. This will be indicated by prefix. The suffix indicates nature of compound. That means whether it is saturated or unsaturated. If it is unsaturated, whether the unsaturation is a double bond or triple bond. Okay, so all these things we have discussed, and we have seen certain prefixes, and we have also seen certain suffixes which indicates the presence of unsaturation. If it is the compound nature of the compound is saturated, we will be using the suffix "ane." If it is unsaturated, that means the presence of double bond, means we will be using the suffix "ene." If it is the triple bond, then we will be using the suffix "ine." Okay, so like this we will be giving the names to the open chain compounds. With this we have completed the nomenclature of open chain compounds. In the next video we will be discussing about the nomenclature of closed ring systems. Thank you. Explanation.